Finally back in the garage and getting prepped to work on the Audi TT. And after messing around with the Audi S5, playing around with the Volkswagen TDI, we are now messing around with the TT, which is a good thing. That will be a beautiful sight to see this thing getting closer. So I'm in the process of transitioning the Motec M182 from the workbench to the engine compartment. I was trying to figure out a good location to mount the ECU, and I decided to kind of stick around with the factory location, and that's what's coming to my mindset at the moment. I don't want to have to run the Motec on the inside of the engine compartment, having to drill holes through the firewall and run wires through there, and just worrying about all kind of other extra grommets and things that I would need to necessitate that transition. But I would rather make it simple, convenient, and that's where the factory ECU was located. It really didn't pose to be any type of major issues from what I've seen in the past, or with my Audi TT with the ECU being mounted there. So why not stick with what's worked with our configuration? So I'm going to change a few things. The original location, the wires ran from across the bulkhead over here, came through into the engine compartment, but I have this monster turbo sitting right here, or semi-monster, or baby turbo. Big compared to the Volkswagen Audi Group typical turbos, but somewhat of a nice size turbo. Instead of running my wires through this side of the engine compartment, I decided to run it closer towards the passenger side. I want to stay away from the heat source as much as possible, and since we're going to have all this bulk heat over in this side of the engine compartment, let's take it over here where the fuel lines and where things will be a little more cooler, and that'll give a lot more life and longevity to the wires or anything potentially being overheated and melting any wires together. We want to stay away from that. I'm going to definitely put some extra heat shielding around the unit, over this side of the engine compartment, and up in here too, just to help protect any type of wires that we have run. But that's what I'm deciding to do. Another thing that I have planned on doing for tonight, because it's already dark outside, is I'm going to remove the valve cover. I want to rotate the engine around top dead center and map out where my direct injection pump cam lobe is interacting, activating, pushing in on the plunger itself for the pump. I want to check my cam lobe and see where is that as far as engine rotation. For example, if the lobe is compressing the pump on TDC or what have you. We'll figure that out once I take all this off, just to pop it up real quick, remove the side housing, and at least we can come up with a strategy of sinking that in with those perimeters into the ECU until I go ahead and fabricate a weld bung and run a sensor through the side of the housing to also map out the location of the pump. But for the most part, I'm going to utilize what the factory did as far as timing sequence. And then we'll get a little more accurate with putting on the sensor. We'll already have that fabricated as well. I have the valve cover removed, and now I'm mapping out the position for my cam follower for the direct injection pump. So it's chain driven. Here's your chain right here. Let's zoom in a little bit closer. And this is my double-sided cam follower. This position of the cam follower is in the up and is not actuated. This little notch is for a tool that you can put in when you're setting the engine up for TDC to make sure this is in a proper position. And this is the roller bearing over here, a roller bearing cam follower that actuates the pump itself. We're going to rotate the engine around and see which position the engine is when it actuates this cam follower right here, this roller bearing. I'm slowly rotating the engine around. I only just moved it a little bit. This was my original mark for where it was lined up for TDC, my reference marks, these yellow paint marks. And I'll just use the example of the way the engine is rotating the moving parts. Now, this intake camshaft is being driven from this side of the engine. This is rotating in a counterclockwise direction, and my direct injection pump cam is rotating, being pushed clockwise. You can see that little notch. That was the reference notch for making sure that the direct injection pump was timed perfectly. What I want to do is, when the engine was at top dead center, I want just to measure one revolution from the piston being at TDC number 1 all the way down to bottom dead center, and then number one piston back up again. Just that one revolution, how many times this pump is being actuated by this single lobe. A lot of camshafts the direct injection pump is driven off the camshaft itself, whereas there's a separate lobe. But on this one, this is a separate type of cam itself that's being driven from off the intake. A lot of times when you're doing research, information may pop up as if it's being driven by or coming off of the number one camshaft. In actuality, it's really a timing chain itself. The timing chain that drives your intake and your exhaust is also driving the lobe, the cam itself for our DI pump. But that's what I want to kind of measure out. So I'm going to continue to rotate this around, count the pulses. So right now, this is being actuated and it's being pushed in. That bottom part of the lobe is pushing in on my pump, and I'm going to count that as one, and we'll continue to rotate around to see how many times that actuates. Now the piston came back up a lot quicker than I thought it would. I just stuck a screwdriver just in reference, just to measure where my piston is as far as top dead center. And my cam lobe has already actuated twice and my piston's back up. I'm going to continue to rotate this around until the engine gets back to top dead center and count the total configurations, I guess, until we get back, and then that way we'll have an idea. And I'll do this a few different times just so that way I have a good sequence. I can see that notch right here is coming back up on, getting closer back to top dead center. You can see my reference right here also for my trigger, for my intake sync, for my camshaft. That is right here, and once it gets back down to this position where the sensor normally picks it up at, and my marks get back up, I'll be back at top dead center. I'll just continue to rotate it a few times so that way I can just overall map it. I was assuming maybe this lobe would have rotated around maybe a lot quicker or even slower, but surprisingly my piston's back up and we only actuated this pump 2 times. Let's continue moving. I have my answers. So we are actuating the pump 3 times per engine cycle. So every time I rotate the engine around and to get back to TDC where my marks are lined back up, we are rotating or actuating my pump 3 times. I rotated the engine twice. I'll do it 2 more times just for total assurance, and then we'll be set with some numbers to plug into the computer and see if we can get this accurately timed first, just off of basic timing, mechanical timing, and then we'll set up the electronic sensor, and that way that'll knock it out with no shadow of a doubt the cam lobe position, and we'll accurately be able to tune that throughout the whole entire RPM band. If that sensor fails, we still have the baseline of mechanical timing operation of pump actuation. I am literally going in circles, and I guess that's the whole point of this, but I want to accurately measure and make sure I have an accurate assessment of how many times that my cam is actuating the direct injection pump. So what I did was, this is the official tool, or not necessarily official, this is the type of timing tool that's used to lock the cam in position. It's pretty nice. There's a dowel pin that goes into this shaft right here for the cam, and it locks that in position. So if you're accurately at top dead center, you have this position that keeps you accurately at top dead center, so that way your pump timing is matching your engine timing and everything is in sync. So now what I had to do also, I'm rotating this engine around, and I also put a reference mark because I'm rotating it around without the harmonic damper, without the harmonic damper on the engine. I put a mark on my crankshaft so that way I can rotate this around and accurately assess this and make sure whether it's 3 times or 6 times. So let's continue to do this and make sure we get it forward. I have it locked in position. Let's take this out. Of course, you want to make sure you take it out so you don't do any damage. And that way I'll watch when this crankshaft goes around, get back at TDC, we'll have a count. Okay, so I have my answer. I was correct 3 times. So the pump actuates 3 times, 1 combustion cycle, 2 crankshaft rotations. We have 3 pulses of our direct injection pump. Now I have some information as a baseline. Now that I have my answer, I can go ahead and put my spark plugs back in, cover this engine back up so that way it doesn't collect too much more dust, and put the Motec back on the bench for the moment. And within hopefully the next couple of weeks, we'll have some numbers plugged into the system. The Motec will be pretty much just mounted there, and a baseline wiring just to see if we can get this engine up and running. Finally, we're getting somewhere. Let's go ahead and cover this back up and get back on the bench for some testing. I have everything temporarily put back together. That would have went a lot quicker and easier with two people. One person could have been rotating the crankshaft while the other person was counting the rotation of the direct injection cam itself. So that got a little tedious. Climbing under the car, rotating, climbing back up over top of the engine, looking back and forth and counting the actuations of the pump. That was just back and forth, and I wanted to make sure I got some accurate information because you definitely have to be specific and detailed to make sure that everything is functioning properly and accurately to get this engine to even idle, let alone run good throughout the RPM band. But that was the main objective, to get that. We'll get the Motec back upstairs on the bench. A few things I want to do now that we have an idea. I want to enter some of that information into the computer and possibly see if we can test the regulator itself, the regulator for the direct injection pump, if we can test that out and get that actuating before I actually come back and do a mock wiring of the engine. I would like to just make sure some of the baseline things are functioning properly first, but it's very critical that we get that timed properly for maintaining rail pressure. If we're not timed, we're not going to make our rail pressure that we need, and also you can be actually fighting the injectors itself if you're not pulsing at the right timing sequence. Those are some of the things we have to take into consideration. A few things I would like to do. I would like to run higher rail pressure, but that's maybe for a future upgrade. We have a lot of things to take into consideration. We can only push possibly a little bit over 1700 psi. The limit I think is like 1730 before this relief valve end up bleeding the pressure back off. But some of the things we have to take into consideration is if our injectors will still flow properly at a higher pressure.
Video out now, man. Like, comment, subscribe.